Good morning, everybody. Now, one thing, at present I cannot record because that facility has been withdrawn from Google's end, and the mail ID which is provided to us by Jadavpur University, in that mail I Google Mail recording facility has been withdrawn temporarily. So if you need, you have to record the screen. Uh, হ্যাঁ, করে নাও, কারণ ঘটনা হচ্ছে আদারওয়াইজ আমাকে সেটা করতে হবে। তোমরা যদি করতে পারো তাহলে আমার আর দরকার নেই। ওকে। So everybody has joined. So let us start the class. Now, in the first semester, you submitted the computation, everybody in time except Ankesh, who said that due to network problem he submitted, but I did not receive it, but he submitted very late, and that's why he will be getting less marks. That's all. Now, in this semester, we have to perform. In the first semester, you designed one voltage doubler circuit, 50 kV output, most probably, so far as I remember. Maybe something like that. Many of you submitted the reports in a very presentable manner. All the screenshots for the simulation in MATLABs and all these things were provided, but some of them uh, submitted the reports very casually. This I did not actually penalize them, though they got slightly less marks. But this time, when you submit the report, be careful. And since you will become engineers after few months, while submitting report, take care so that it is presented in a acceptable and presentable manner. Just writing on the piece of paper without typing handwritten things you are submitting in report in semester examination, that is all right. But in when you submit report, it should be typed and presented in a manner which is readable at least. And the drawings, graphs, etc., should be plotted nicely. Otherwise, it will create a bad effect in future also. This is a guidance for you. This is one suggestion. While submitting the report in this semester, you just be careful about these points. So in this semester, we shall solve two problems. We have to solve two problems. And these two problems will be mostly based, not mostly, fully based on computational techniques, etc. Now, you have studied finite difference method by this time in first semester class, and the problems will be based on finite difference method. The first problem will be very simple problem. It is computation of electric field, not field, electric potential, because in finite difference method, we cannot directly find out the electric field. So we have to find out the potential in at different nodes in between the two plates of a parallel plate capacitor. That will be our first problem. And the second problem will be the computation of electric potential at different nodes in a single core cable. So I'll show you the two problems. Let me go to presentation mode. Can you see this, or should I enlarge it slightly more? Okay, so this is the first problem. Measurement of electric potential at various points. It should be nodes to be more specific. taken between the electrodes of a parallel plate capacitor. Now, objective is to determine using 2D finite difference method the electric potential for grid for a grid of points located between the plates of a parallel plate capacitor whose electrodes are at finite non-zero potential and ground potential. This is a diagram. Say the upper plate. This is the upper plate which is held at a suitable potential, say V kV or V volts, whatever, and this plate is held at ground potential, and the space between them are divided into grids like this as shown in the figure. You can change the number of grids as according to your requirement. But if you can place or form the nodes which are equidistant, then it is easier to solve the problems for this type of problems. And using finite difference method, we know in a two-dimensional system, the potential of the central node will be equal to 4, V1 plus V2, V1 plus V2 plus V3 plus V4 by 4. Now, equidistant node, yes. So if you can arrange the nodes at equidistant, or which, if you can place the nodes which are at equal distances from each other, then you can directly use that formula. But the point is this: in a parallel plate capacitor, in ideal case, we know the potential at a distance from a particular electrode, say from the live electrode, the potential along this line, all the nodes lying on this line will be at same potential. Ideally, that is valid. Similarly, considering other horizontal, second horizontal line from top, if we consider the nodes any or the number of nodes on this line, all the potential of all these nodes will also be same. Similarly, for the other horizontal lines. Therefore, our approach will be, first of all, we know the potentials of the vertical, top boundary, that is the live electrode, which is, the potential of all the nodes lying on the upper boundary or upper electrode, which is held at live potential, will be equal to V, say. At the same time, the potentials of all the nodes lying on the ground electrode will be zero. And in order to apply finite difference equations, it is always advised that other two boundaries, that the other two side boundaries, this line, this one, and this one, there, the nodes lying on these two boundaries should also, their potential should also be specified. So here the potential varies linearly. If you see, if this is V and this is 0, then the potentials of, what will be the potential of this node? 0 by V divided by number of nodes. 0 by V, V minus 0 divided by number of nodes. And here it will be V minus 0 divided by number of nodes into 2. Here it will be 3. Like this, linear variation of potentials will take place along this boundary. And also, the potential on the other side boundary along the same horizontal line will also be same as that of this potential, or the potential of this node. Therefore, after defining the potential, all the potentials of the boundary nodes or the nodes lying on the boundaries, then we have to go for finding the potential. We have to find out the potentials of the central nodes. Here in this diagram, there are 9 nodes. This 1, 2, 3, 4, 5, 6, 7, 8, 9. The potential of these 9 nodes has to be computed. Now, here, uh, I'll suggest you use iterative techniques For finding out the potentials of these nodes, considering the potentials of the boundary nodes are to be known, you go or apply some iterative techniques so that we can find out the potentials of the inner node. Again, so that will be our first problem. After finding out the potentials of the inner nodes by your own programs, I'll request you to verify the results using MATLAB or some other computing software, computing tools, and check whether the results obtained by you, by your own program, tallies with that, or how much percentage of error is there. While writing the equations, for better accuracy of results, you need to go for some more number of nodes. So as the number of nodes increase, the number of iterations will also be more. Now, for quick convergence, you have studied in your high voltage elective class that we usually include one parameter in our equations or in our programs, that is acceleration factor. So yes, A, that you include in your program so that the iterations converge quickly. And finally, after comparing the results obtained by you by your own program and with that of MATLAB or some other technique, or using some other computing tool, what all you have to do, you have to plot the entire thing. I mean, here, this is a two-dimensional diagram where the upper horizontal lines stands for the live electrode, the lower horizontal line stands for the ground electrode. There, you just draw a better or nice diagram where you just show this is the live electrode when, leveling this, the voltage of which to be equal to V, and this you connect to ground with the proper symbol and like this, and show the nodes with their numbers. It may be like this: 1, 2, 3. All the node numbers should be mentioned over here. So, this grid formation, you present it or draw it in a better way, leveling all the things, V, the node numbers, here connecting it to 0, etc. Now, you are 10 in this group. So, for the first 5, that is, I tell you, mm, it starts from Sumanto, na?
Yes, sir.
Starting from Sumanto, it is up to Puja. These 10 are here in this group, isn't it? So, uh, Sumanto, from Sumanto up to Puja. Sumanto, Ankesh, Pawan, Sinjan, and Rishabh. These 5, for these 5, you consider V to be 8 kV. And for the rest, that is for Victor, Shreya, Anish, Rahul, and Puja, you consider V to be 6 kV. Now, the number of grids, I'm not specifying, that you select according to your requirement. So this is the first problem. If you have any question or any query regarding the first problem, you can ask me. আছে, আছে। MATLAB এ ফাইনাইট ডিফারেন্স মেথড, ফাইনাইট এলিমেন্ট মেথড সবই আছে। হুম, হুম, হুম। হ্যাঁ, রিপোর্টে তো শোনো, রিপোর্টে যেটা করতে হবে প্রথমত তুমি এই ফিগারটা দিয়ে এই প্রবলেম স্টেটমেন্ট দিলে, অবজেক্টিভ লিখলে, ফিগারটা দিয়ে প্রবলেমটাকে ডিফাইন করলে পুরোটা। তারপরে তুমি তোমার নিজের প্রোগ্রামের যেটা আউটপুট, প্রোগ্রামের এটা খুব বড় প্রোগ্রাম হবে না। চাইলে প্রোগ্রামের প্রিন্ট আউটটাও দিয়ে দিতে পারো। মানে ওখানে অ্যাটাচ করতে পারো ফাইলে। এবং প্রোগ্রামের যে আউটপুটটা পেলে সেখানে একটা জিনিস করতে হবে। সেটা হচ্ছে এগেইন এই প্যারালাল প্লেট ইলেকট্রোডটা করে, মানে ড্র করে তার মধ্যে ইকুইপোটেনশিয়াল লাইনস যেগুলো আছে সেগুলো ড্র করা এবং তার সঙ্গে ফিল্ড লাইনস গুলো ড্র করা। ঠিক আছে? বোঝা গেল? ওইটা করে দিলে তারপরে এবারে তুমি MATLAB এর সঙ্গে কম্পেয়ার করলে, করে তুমি সেটা একটা রেজাল্টটা ট্যাবুলার ফর্মে দিলে যে যতগুলো নোড, প্রত্যেকটা নোডে তুমি যে ভোল্টেজ পেয়েছো, অবভিয়াসলি বাউন্ডারি নোড গুলো বাদ দিয়ে, বাউন্ডারি নোডের পোটেনশিয়াল দুটো ক্ষেত্রেই সেম ধরেই তোমায় করতে হবে। তাহলে এবার ইনসাইড নোডগুলোর ক্ষেত্রে যেটা করবে সেটা হচ্ছে যে তোমার প্রোগ্রাম থেকে কত মানে রেজাল্ট কি পেয়েছো, ম্যাটল্যাব থেকে কি পেয়েছো, দুটোর মধ্যে পার্সেন্টেজ এরার কত হচ্ছে, এবং তোমার প্রোগ্রামের রেজাল্টটাকে স্ট্যান্ডার্ড ধরে। কেমন? এনি আদার কোয়েশ্চেন? আর একটা জিনিস সেটা হচ্ছে যে এই প্রবলেমটা সাবমিট করার জন্য আজকে তো 1 তারিখ, 15 তারিখ ডেট থাক।
Okay, sir.
বেশ। হ্যাঁ, ফোন করে নেবে আমাকে, তখন আমরা আর একটা ক্লাস সেট করবো। নো প্রবলেম। আচ্ছা, আর 3 তারিখ থেকে তো খুলেই যাচ্ছে। তোমরা তো আসা যাওয়া শুরু করবে, আমরাও যাতায়াত শুরু করব। তখন সামনাসামনিও কথাবার্তা হতে পারে, অসুবিধে কিছু নেই।
ঠিক আছে স্যার।
তোমরা কি ঠিক করেছো, ক্লাস কি ফিজিক্যাল মোডে করবে নাকি যেরাম চলছে সেরামই করবে? না, না, আসবে তো ডেফিনিটলি আসবে। কিন্তু ঘটনা হচ্ছে আসা আর ক্লাস করা তো এক না। তুমি ধরো আসলে ল্যাব করলে সব ঠিক আছে। এবার থিওরি ক্লাসগুলো কিভাবে করবে? এই সেমেস্টারে তোমাদের তো বোধহয় খুব বেশি থিওরি পেপার নেইও। ইলেকটিভ আছে আর কি আছে? হ্যাঁ, 4টে পেপার আছে বোধহয়, তাই না? থিওরি পেপার 5টা, এবার বেড়ে গেছে একটা ওই অনার্স পেপার এসে যাওয়ার জন্য। ঠিক আছে। So, is there any other question regarding this?
No, sir.
Okay, so let us move to the next problem. Next problem is this one. This is the problem. Okay. So now this is the second problem. Now again, this is a single core cable having two dielectrics wrapped over the conductor. Here, as it is mentioned in the problem in the diagram, radius of the conductor is 2.5 millimeter RC. Conductor is held at a potential of 1 kV. R1, the radius of the inner dielectric is 4 millimeter, and radius of the outer dielectric is 5 millimeter. Relative permittivity of the first dielectric is 2.5, and relative permittivity of the second dielectric is 3.5. Now the thing is this, you have to compute the potentials at different nodes uh, within the dielectrics at different radial distances. Now, so far as this system is concerned, truly speaking, this is an axisymmetric system. But in a single core cable, we know that the potential at a particular radial distance will be same on all the points which are located at same radial distance from the center of the conductor. So the potential truly varies along, I mean, for an axisymmetric system, it is r theta z. So we see that this system for this single core cables, it is the potential variation of potential is independent of theta. It varies with r and z only. Okay. And again, uh, so far as the z is concerned, if you consider any cross section along z, the variation of potential will be same. So the potential variation will be only with radius r1, r2, etc. So here, what all you have to do, you don't have to consider the entire cross section. Instead, you consider a thin triangular strip like this, right? Therefore, if the strip is thin, then the two external boundaries, one lying on the conductor surface and one lying on the outer dielectric, for them, though these two boundaries are really practically curved surfaces, but for all practical purpose, if the uh, cross-sectional area which we have considered is thin enough, then we can approximate these two external boundaries by straight lines. Yes. So result will be a trapezium. So there you just find out the nodes on the boundaries. That is again the nodes lying on the outermost boundary will be held at zero potential. The nodes lying on the conductor surface will be held at ground potential. Sorry, 1 kV as per our problem. And the nodes lying on the two side boundaries, you have to calculate the potential for that. Now we know that the potential, there is well-known analytical relationship using which we can compute the potential at any point at a distance from the conductor of a single core cable. That is already known to us. We have studied in power system classes, also in field theory classes, that relationship you use to find out the potentials on the nodes lying on the side boundaries. Yes, thereafter there will be inside nodes also. So you have to calculate the potentials of the inside nodes, but this time again, Yes, and also here it may not be possible to make the nodal distances e- equal to each other. You have to go for dissimilar nodal distances. For that, the equations will also be different. So all these things you have to take care. And after obtaining the result, how will you understand that you have got the correct result or not? Along the radius, na, uh, along a particular radial distance, it will be independent of theta. Oh, exactly. You have to find out or use the same formula for finding out the potential at any node within any dielectric. Do you understand? You have used some formula to find out the potentials of the boundary nodes lying on the side boundaries. Now, if you can find out the potential at this point or at this node, using the same formula, you can find out the potential at some other node also. And then you can compare the potential of that node with your results of your program. Okay? So first you concentrate on this problem, this one. After you finish it on 15th, you submit your results. Thereafter you take up this problem, and that this problem has to be submitted before the sessional classes dissolve. Okay then. Question about this problem. সেটা হ্যাঁ ঠিক আছে, হ্যাঁ ঠিক আছে, ওকে। আমি কি প্রবলেমটা পাঠিয়ে দেবো পিডিএফ করে সবাইকে তোমাদের গ্রুপে? হ্যাঁ ঠিক আছে। আর কোনো কোয়েশ্চেন আছে?
না স্যার।
বুঝতে পারছি না, বলো। না, এটা 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 ভোল্টেজ আলাদা করে কিছু বলছি না, এটা 1 কেভি যেটা দেওয়া আছে সেটা ধরেই করো সবাই।
ওকে স্যার।
Okay, then I'll send the two problems, PDF of these two in your group email ID, just right at this moment. Okay, thank you very much.
Thank you, sir.
Ankesh, are
Thank
you
you, sir.
here? Ankesh,
Yes, sir.
fine. Are you here? Can you hear me?
Yes, sir. Yes, sir.
Acha, you submitted the computation report. I saw it yesterday. What was the problem?
Sir, that was single stage voltage doubler circuit.
So what you submitted contained actually multiplier circuit. Okay, that is also accepted. Somebody wrote voltage doubler circuit is a part of multiplier circuit. Okay, fine. You also included in your report single stage impulse generator circuit and what not. Why all these things you included in your report? You downloaded it from some site and
No,
included
sir.
it in your report.
I sir asked from a friend to he tell me that means sir
But
means
none of your friend included impulse generator. Some
no
of
sir this friend
included
not sir.
multiplier circuit, etc. mentioned, not the
SD
design of
sir
multiplier. Yes.
SD sir means sir I watched some videos of SD sir. Sir he
So that
was
you
teaching me.
included. That you included.
Sir I thought that you also means there was only one class of yours so I got confused. Means
You got confused. The problem was that very much with you. If you got confused, you could ask me.
I thought sir you have also given that so that's why I added.
You just added. You thought something and just added. But none of your friend did like that. Anyway, okay. Okay then. So you tell me when will be our next class? Okay, should I send you the link? Please take some time because if everything reopens, then the class can be held in physical mode. We can meet physical in JU. That is Tuesday second up. And if that is not possible, then we shall have online class. So that can be fixed, finalized after third. Okay, thank you.
Thank you, sir.
Mm.
Thank you, sir.